To introduce them each, Brian Black is the CEO of Radio Data Networks. Toby Greenwood is the Business Development Manager for CMCL. And Phil Williams is the Director of the Environmental Protection Group. So we'll start with Brian.
Well, thank you. Unusually, I've decided I'm going to bring along the thing I'm going to speak about to prove one thing that's key to this presentation, portability. So this is about a little bit of a journey, a bit of a story, which has resulted in the gauging station in the box we're talking about. Obviously, we know we have lots of challenges we have to face ahead. And it's not just flooding, it's also the converse, drought resilience, and also safety that was mentioned earlier by a gentleman from Network Rail. It's a thing that also is not just an urban problem, it's also a rural problem, and it's in areas that are ultra remote, as again, railways particularly are. And it's something that also, we have a challenge where we have this real problem. Do we exude lots and lots of carbon building huge flood schemes as the one I worked on there up near Birmingham? Or do we think about net zero as well? Because if we don't look at the two in balance, we could end up with a vicious circle of making things actually worse. So what is required to achieve a lower carbon method of flood reduction? And my opinion is, and it's shared by many, is to reutilize what we already have. It's sweating the old assets, making drainage and flood schemes and dams and weirs and so on work a lot better than they really do. And it's a matter of, the key to that is retrofitability. You must get whatever you develop and have to work better and work with what's already there. So that's the key thing. And on the left-hand side, just to illustrate things, that's a traditional gauging station that's used by the Environment Agency, one we've developed years ago and supplied with them, which took about 9 months to install. Probably cost the best part of 75,000 all in, with all the planning and applications that go on. And the problem is, and the net result is, you've only got about 1,500 gauging stations around England because of this problem of trying to get them in, install them and so on. And that's serving 5.2 million and literally 200,000 kilometers of streams. So we are talking about granularity. We've got very granular data, which is not suitable for the projects mentioned earlier, like these FCRIT projects, where we're looking at local flooding down to sub-catchments and catchment levels, where you need intimate detail within that catchment. And also the ability to prove the models that people generate are actually working. So we've taken the best from highways, we've taken the best from rail, all the things we've learned over many, many years and brought it together. Because what we don't want to do is have the usual boundaries of adoption saying, it's new, it's scary, we're not going to use it. So we've been down that road before. So the gauging station in the box, which I'm presenting here now, as I can pick up here in one hand, is what you saw earlier. It has all the features you saw earlier. It has all the same radar technology and so on for level measurement the EA have adopted and so on. So all the good stuff is there, no compromises. But what we've added to it is the thing that the railway industry have loved and why they've adopted it, is also it's got multi-mode communications built into it. So not only do we have a local facility to make smart networks where we can control local assets like this particular weir on the CSO, but also we have Iridium satellite built into this unit too, which means we deliver data from anywhere. And that's been proven by Network Rail, who've trialed this with Riddick, their research center, and actually demonstrated we worked everywhere without fail. Obviously, to make it tough was key. Also to make it lightweight. So we've had a real balancing act here because it has to be portable. Again, if you refer to railways and so on, you've got to carry it down the track bed. You've got to walk all the way to site to install these sort of things. So we've got built-in carrier handles, and also we've made it bulletproof. Sadly, children love shooting out assets. It's a great, sad situation we have in these modern times. And the other thing is installation. You know, people say, you can't drill this, you can't do this, you have to do structural analysis and so on. So the way we've approached it, we spoke to highways, spoke to the EA, we spoke to everyone and said, what floats your boat? Non-evasive was the word that everyone came back. So everything we've done is been clipped and clamped and locked securely to existing infrastructure. We haven't had to alter a single thing or drill a single hole in any installation, whether it be in railways or on this FCRIT project as these pictures are taken from. So it's adaptation. The other part that's been very, very important has been the ease of use, setup and so on. So we can set it up with a Bluetooth app on your phone, so you don't need to climb up on the structure to touch it. And then you get live data stream. When I say live, it's not stored like a data logger. It's a live stream, 5-minute real-time data. So therefore, you can see actual responses to rainfall. Yes, we have rain version as well, rain gauges as well, which integrate in the same system. And that means you can actually prove that the assets that are supposed to be creating flow attenuation are actually working or not, as in the case of this example from one of these FCRIT projects, where we suspect things could be done better. So this has only been introduced in 2022 during the summer, but yet we've already been adopted on one of the big FCRIT projects. We've also been used on the converse for angling water for drought deficit monitoring and so on for chalk streams. Southern Water are using it in drainage infiltration, so it's been used there too. And Transport of Wales just last month have adopted it for the entire Coral Valley rail network for track flood monitoring. So in a short period of time, the whole concept of portability, lightweight, low cost, which is very important if you look at the summary of all the assets and attributes we have here, we think they're probably saving 80% of the cost compared to a full-blown installation. And if you get it wrong, which is one of the fears of people putting engaging stations, you can pick it up and move it. It's not a fixed thing. And also, if you do improve the flow in the catchment, again, you can move it, you can repurpose it, recycle it. That's why I put the big thing on the bottom. It's a recyclable product in every single way, because you can move it, repurpose it. You're not stuck. But one of the most important things, and the thing I mentioned earlier and the question I raised, is about our future will require using assets we have better. That will require using smart control of existing pumping stations, existing weirs, existing assets. And this also provides that feed, which is 100% cyber secure. Because the thing I didn't mention earlier is none of this data touches the internet. So Iridium goes via a satellite service, which doesn't use IP connection. And similarly, the local communications here uses an Ofcom licensed radio channel, again, very secure because it doesn't touch the internet. So it's perfect for this smart network's local control of assets. And that is it, in a nutshell, the gauging station in a box. Thank you.